Myself Jaishree Jain, Assistant Professor in Computer Science and Engineering Department from AKGEC Ghaziabad. Today I will deliver the lecture on the topic image representation and descriptors. This is a topic of Unit 5 in image processing. So in this topic we will understand how can we identify the information from the object that we have recognized in the last unit, like in image segmentation we have identified different objects. Now we have to describe the information about those objects that are identified. So the name like image representation and descriptor, so we have to use different descriptors so that we can identify the information, means object shape or color and texture and all that. So there are different information. So we can, with the help of descriptor, we can find out the information of the different objects. So now understand about the we will understand about image representation and descriptors. So what is a representation and descriptor? Representation means representing regions in two ways, like based on their external characteristics, means like boundary. So we have to represent the object in the form of any shape. So we can find out the shape characteristics of any object. And next is based on the internal characteristic. Internal characteristics property are like color and texture of the object. So we have to identify the external characteristic like outer boundary or shape of the object, or there can be some internal property like color or texture property of the object, or it can be both. So these are the different ways we can find represent the object in the in this form and find out the property of the object. Next is, so what is description? Description means that describes the reason based on the selected representation. So representation is like boundary or texture feature. We have to identify the boundary value, or we have to identify the shape or texture of the object that is covered under the representation part. And description is the length of the object or orientation of the object and number of concavity in the boundary. Means if we have selected one shape or one boundary, then there can be any concavity, like this is the shape, so this is the concavity here. So we have to identify the concavity in the boundary. Statistical measures of the region means what are the how many curve are there, or what is the texture. So there can be different characteristics. So description means like metadata of this representation of that object will cover in the description. So basically, basic introduction is after an image has been segmented into the regions. In last unit we have understand the segmentation. So we have divided our image into number of regions. So then resulting pixels is usually represented and described in suitable form for further computer processing. So we have segmented our image and find out the different region. Now we will represent these regions in the form of their characteristics. Like we have two choices: external characteristics like boundary, and internal characteristics means that is based on the pixel value. So above task is making the data useful to the computer. So we will get the discovery, we will get the description of the object. So new task is to describe the region on the basis of the representation. So we have finally we have some information like in Facebook, when we tag any face, then it will give the information who is the person, what is the name of the project or ID, name of the person or ID of the person, or mobile number or contact number. So this is the same task we are going to perform here. Next is, so external representation, primary focus is on shape, I already told, and in internal characteristic we have color and texture characteristic of the pixel. Sometimes it is possible to choose both characteristics, and features selected as descriptors should be insensitive to change in size, translation and rotation. So whatever the information, like I draw this shape, so I will rotate this shape in 90 degree or 180 degree. so it will remain insensitive if I am going to making the rotation of the object or translation or changing the size of the object. So representation involve different technique. So we can say these are the different technique. First technique of representation is in the form of chain code, then polygon approximation, in which we have to apply the minimum perimeter polygon, merging technique and splitting technique. Next is signatures and boundary segments and skeletons. So these all are the technique we have to apply in representation of the object. So first is chain code. So in this chain code we have to make some coding, and according to that code we can identify the shape of the object. So first rule is to represent the boundary by the connective sequence of the straight line segment. So first is we have to draw the straight line in this cross manner and assign the code in this manner, like this is from left side. First is 0, then anti-clockwise we will do it 1, 2 and 3. So this is the 4, this is called as 4 connectivity chain code. So if we getting any, if we have any image like this one, so we have to find out whether like this is in the direction of left direction I am going to start. So 0 is there, 1 is there, then but this image is in the curve form. So this is the straight line chain code. So we have to select the object in the form of straight line. So this is the object. Now we can find out the chain code of this 0, 1, 2 and add down it is 3. Fine. So this is one dimension, and other one is the 8 connectivity node. So in this case we have diagonal 2 diagonals and 2 straight lines. So the code is assigned from here 0, 1, 2, 3, 4, 5, 6 and 7. So these all are the different code. In case of 8 connectivity we will represent this chain code. So the boundary code formed as a sequence of such directional and directional number is referred to as a Feynman chain code. So we have a directional code called as chain code. So chain code can be generated by following the boundary in say clockwise direction and assigning direction to the segment connecting every pair of the pixels. So we have to we will count chain code in clockwise direction like this. So unacceptable method, resulting chain tend to be quite long. What are the disadvantages of this technique? In this technique actually the image can be, the object can be of containing very diagonals or straight lines. So the chain code can be quite long. So it's very take the complexity. Any small disturbance along the boundary due to the noise or imperfect segmentation can cause the changes in the code. So this is the disadvantage of this technique. So this is the example, like this is one kind of shape of the object, and here we have different segments. So if I am going to start from here, so it will be read in clockwise direction 0, 0, 0, then 3 in the downward, then 0, 0, then 3, 3, 3, 3, 3, and here we have 2, 2, 2, 2, 2, 2, and here we have 1, 1, 1, 1, 1. So this is very long chain code. So accuracy of the this code can be very if there are some noise and all that. So this is very long code. So given a chain code of 1 to n code, so we will have n plus 1 code. Total, if we have n nodes, then we will have the n plus 1 chain code. So this is a representation 4 directional and 8 directional, and chain code represent the boundary of a connected region. So this is one point. This is the example how can we find out the chain code of the object and can normalize those objects. So firstly, this is the shape, and by counting the this is the starting point. From here we will count the shape in clockwise direction. So first is 0, in left side, then down in downwards we have 3, then 0, 3, 2, 2, 1, 1. So we will get this chain code, that is the initial chain code. Then we have to normalize this chain code. So firstly we have to find out the start point, then starting point, then reflex and rotation. So we have to check whether there is a effect of rotation of the object or reflex. If we are going to change the direction of the object, then it will going to change the object shape or not. So this is the starting point, and this is a 4-point and 8-point chain code. So firstly we have find out the initial chain code. So this is another example. The shape is like that, and firstly we will make some boundary point. So here there is a boundary. This corner is called as a boundary point. So firstly we have to find out the boundary point, then connect these boundary point and find out the chain code in clockwise direction. This is the another shape. We can find out the this is 8 connectivity, so we can find out the chain code number in this direction. So how to step to find out the normalized chain code? Firstly calculate the chain, calculate the circular first difference and normalize the chain code. So firstly we have to find out the chain code, then we have to calculate the circular first chain code difference and then normalize chain code. So chain code can be based either on the 4 connectivity and 8 connectivity. The first difference of the chain code, how can we calculate the first difference? If this is the, for example, the first difference of 4 directional chain code, this is a 4 directional chain code and we have to calculate the difference. So we have to start where we find out first 3. So this is the 3. So firstly we write 3 and make the difference. 3 minus 3, 1, then 3 minus 3, 1, then 3 minus 2. Here we have to calculate the difference. First difference, that is 3, 3, 1, then 3, 3, 0, 3, 0. How can we calculate the first difference? Here we can easily calculate the first difference. This is the shape, and here we have to calculate the shape number. From this we track this number 0, 3, 0 and 0, 3, 0, 3, 2, 2 and 1, 1. So this is the first step. Firstly we have to calculate the normal chain code. After that we have to calculate the first difference. So first difference we will find out first number, that is 3. So first 3 number is here. So we will write 3 here, and again we have to find out the difference. So 3 and next number is, from here we will start the list 3. Then difference is 3 minus, this is the 0, 3 minus 0 is 3, then 0 minus 3 is 3, then 3 minus 2 is 1, 2 minus 2 is 0, just wait. So 0 minus 3 is 3, and next 3 is here. So 3 minus 3 will be 0 and 3 minus 2 will be 1. Just wait. Normalized chain code. So firstly we have to choose the starting point, and from the starting point we will calculate the chain code number. So we have to calculate the chain code here, 0, 3, 0. This is the first chain code, 0, 3, 0 and 2, 2, 2, 1, 1, 0, 3. So this is the first code, and after that we have to calculate the first difference. From first difference we will calculate from here. First 3 is here, then write it. Okay, 0 minus 3 is 3, and next 3 minus 2 is 1, 2 minus 2 is 0, 2 minus 1 is 1, 1 minus 1 is 0. Firstly write this, 0 minus 3 is 3 and 3 minus 2 is 1, 2 minus 2 is 0, then 2 minus 1 is 1 and 1 minus 1 is 0 and 1 minus 0 is 1 and 0 minus 3 is 3 and 3 minus 0 is 3. Okay, then rotate this from here, like, so we will get the code 33131010133. Okay. Sweet. So here we will calculate the reflection. If I just make this object in opposite direction, so if I reflect this direction in opposite direction, then we have to check whether the both code is same or not. So firstly we will calculate from this side. So 0 3 0, this is the starting point, 0 3 3 2 2 1 0 and 1. So we will get this code. This is a chain code, and then we have to calculate the first difference from here. Then 0 minus 1, just pick up from here. 0 minus 1 is 1, and next 0 minus 3 is 3, and 3 minus 3 is 0. Next 3 minus 2 is 1, and 2 minus 2 is 0, and 2 minus 1 is 1. So calculate the first difference, and then we have to find out, actually last slide, this one. Now we have to start where we will get the first normalized code, means we have to start from here. So first number is 0, and next we will start from 3. So 3, and next is 3 1 0. So if I am going to make this object in opposite direction, if I am going to rotate this object, and this is the starting point, then we have to calculate from here 1 0 0 3 3 2 1 and 2. So this is our chain code, and then we have to calculate the first difference of this chain code. Then so we will calculate the first difference. First is 3. From this, here we have to calculate. 3 is written here. 3 minus 3 is 0, and next is 3. 3 minus 2 is 1. Just calculate it. 3, and 3 minus 3 is 0. Then 3 minus 2 is just write 3 as it is, and 3 minus 2 is 1. 2 minus 1 is 1, and 1 minus 2 is 1. 2 minus 1 is 1. So this is the first difference, and then we have to calculate the normalize. Actually, these are the steps. How can we calculate the first difference? These are the steps. So difference is obtained by counting the number of the direction changes in a counterclockwise direction. So firstly we have to calculate the counterclockwise direction, and for example, the first difference of 4 direction chain code of this is this. So assuming the first difference code represented a closed path, rotation normalize can be achieved by circularly shifting the number of the code so that the list of number forms the smallest possible integer. Okay, so we have to rotate it. So first 3 is here we get, and then next number is 1, 3, next number is, from here we circulate this from here, then 1, then we have 3, and 3 3 0. We have to calculate the actually difference. First we have 3 here, and then rotated from here we will get the value, that is 1. Sweet. Okay. So from this slide we can easily understand how can we calculate the first difference. Chain code represent an orientation, and the rotation result in a different chain code. So use the first difference of the chain code instead of code itself. So the difference is obtained by simply counting counterclockwise the number of directions that separates two adjacent element. So firstly, from this shape, if this is a chain code 2 1 0 1 0 3 3 2 2 2. So firstly, I am right from here. This is 3 3 3. Okay, then these number will be written here 3 3. Then circulate is it clockwise. Clockwise means 3. After 3 we will get 2. So at clockwise, if we move it, just wait, 2 1 2 1 0 2 1 0 1 0 3 3 2 2 2. So we have to calculate the difference code. Sorry, this is 1. This is 1 1 0 1 0 3 3 2 2. If this is our chain code, then we have to calculate the first difference of this code. So from here we will start 3 and circulate it from here 3, then 1, and after that we have next 3 is here 3. Then find out the difference. Next is rotated 3 minus 0. 3 minus 0 is 3, and 3 minus 0 is 3. Then 3 minus 2 is 1. 3 minus 0. 0 minus 1 is 1, and 1 minus 0 is 1. And after that we have 0 minus 3 is 3, and 3 minus 3 is 0. So firstly we have to calculate the first difference, and after that we have to normalize this code. For normalizing, we will start from first 3 we will get here, like this is the chain code and this is the first difference. Then we have to considering the circular sequence. First element is calculated by subtracting the last and first component. So last and first component, last component is 0, first component is 3, the difference is 3. Fine. Next number is, then we will start from next 3. Next number is start from here 3. Next 3 is this. Okay, then we will next circulate it. Next number is 1. Next 3. After that we have 0, 3 and 0. Fine. So firstly we have to calculate the difference between first and last element. We calculate 0 minus 3 is 3. Then this 3 is written as it is here, and after that we will repeat this code 1 3 3 0 3 0. Fine. So this is called as a normalized chain code. Next is polygon approximation. In polygon approximation, the digital boundary can be approximated with the arbitrary accuracy of a polygon. So this is the name like polygon. So we have to approximate the boundary of the polygon. So for closed boundary, approx become exact when number of segments in the polygon equal to number of point in the boundary. So it depends the number of point, how many points are in the boundary. So same number of segment will be in the polygon. So goal of the polygon approximation is to capture the essence of the shape in a given boundary using the fewest number of segments. So this is a polygon approximation technique in which we have this polygon in this shape, and we have to just normalize or approximate this polygon. So only the minimum required number of sides necessary to preserve the needed shape information should be used. So we have to just check what is the boundary of the each and every segment. So here we have the boundary point, here we have the boundary point, this boundary point, this boundary point. So after that we match the boundary point. So how can we find the boundary points? So if this is a shape, firstly we have to check what are the inner boundary point of this. Inner boundary point is represented with red lines, and if this is the segment and this is our boundary, so we will take inner and outer boundary point. Outer boundary point is here represented with green. So we have the now we have to take the match this lowest boundary point with the this next boundary point, and this from this boundary point we will just connect with the next boundary point, then next. So this is the manner how can we approximate this polygon. Firstly connect the first point and next internal boundary point segment to the straight line, then we will connect this point to the next boundary segment with straight line. After that we are now check where it will lie. So first point is here and next point is lie between here. If I choose this point, then it will be straight line and this object will be outside. So we have to just check what are the different segment point we can connect. So these are the example of polygon approximation. Fine. So the cellular approach reduces the shape of the object enclosed by the original boundary. So, so these are the two techniques we have learned in this topic. So first is chain code and next is the polygon approximation technique. So next technique we will learn in the next lecture. So thank you so much.